Okay, it's recording now. The question is, do we want to read the doc silently to ourselves, or does Alex want to present the doc to us? Or both? It looks reasonably short. Want to take 5 minutes to read?
I'm in favor of reading.
All right, let's read.
For 5 minutes, yes?
Yes.
Okay.
Yep, sounds good.
So it's been 5 minutes. I see a lot of people writing questions.
So
You want
many
more
good
time?
questions.
More time to read?
I recommend we jump into talking.
Yeah,
And let's okay. Actually, let's ask. That's right. The point is to ask anyone if they need more time to read, right?
that's what I'm.
Versus, but the point is not time to write more questions. Is right? The focus is there's no need more time to actually read the doc.
Yes. All right. 3, 2, 1. Let's do it. I'll happily take some notes. But there's this question queue. Maybe we'll go down them. Alex, you can pick which one you want to answer first.
Sure. I mean, do you want to just like go down top to bottom and like read the
Yeah,
question and
why
talk
not?
about it? All right. So what makes Wasm binding rely on this existing C ABI? So this is an implementation specific thing in Wasm binding, obviously, but the idea is that Wasm binding is all about communication between Rust and JavaScript, and JavaScript is working with the Wasm module that is actually working with, and so we have to like Wasm binding, the tool and the macro has to generate an ABI that both JavaScript expects and the tool expects to be generated. So the idea is that every type has a well-known ABI for how it crosses this boundary between JavaScript and Rust, and then the JavaScript code generator can just assume the Rust type signature looks that way. So basically, we're using extern C because we need the agreement, and then the difference happens where right now there's the way that it works is the macro, you write a function that has an argument, and then that argument is expanded to another argument in an ABI style form. So we kind of lower like the argument that you give to the ABI, but it's a one-to-one mapping, like a one-to-one mapping of the parameter that you wrote in your Rust function as a parameter to what's actually going into the C ABI function. And so, for example, strings are passed as a pointer and a length, which is 2 values. And so we rely on those 2 values to be splat into the argument list, where like even when the C ABI function takes 1 parameter, it's actually 2 parameters at the ABI level, and that's because the JavaScript expects that. So the difference here is that in the C ABI, like the canonical C ABI with Clang, that single parameter, which is 2 32-bit values, is passed indirectly, and the JavaScript could agree with that. The JavaScript could do that, but it doesn't today. And so if we were to land this change on nightly, it would break anyone. Like Wasm binding would have to change. It would only be compatible with that version. So that would just cause a lot of breakage, a lot of issues there. But does that make sense for why it's reliant on the existing one? It's kind of difficult to migrate.
I think so. I think you're saying, so first of all, it seems like some of this logic is baked into Wasm binding. Is
Yeah,
that
it
correct?
has everything to do with how the macro expansion currently works, and how the macro expansion assumes that like we can take your given type that you wrote in your function and then use traits to project that to a different associated type, which we assume is an argument in like an extern C ABI, and then we make assumptions about that projection as an argument, what the ABI should be.
Yeah. So you can use traits to map Rust types to simpler Rust types that the ABI sort of natively understands.
Right. So like
And
the
then
Rust
there's
type is.
extent.
Sorry, go ahead.
So, and then there's extent JavaScript code that is also based on that assumption.
Right. There's the CLI, which then says that like, oh, okay, your Rust function took a string as an argument. Therefore, I'm expecting the ABI is you take 2 parameters, which is the pointer and length.
And so you kind of have, there's a bit of a problem of making them, updating them both. It's like a chicken and egg problem.
It's not so much that like it would be given a compiler, it would be pretty easy to just write and update Wasm binding to do the correct thing. Like we can just say that JavaScript expects it to be indirect pointer. The bigger issue is nightly beta stable, where like if we were to land this, then like basically some version of Wasm, like there's just some breaking point where like if you have this Rust version, you can use this Wasm binding and below, or if you have that Rust version, you can use this Wasm binding and above. And that breakage has not been something that I wanted to deal with.
And it's not possible to use like a config version or something, you know, once that stabilizes, because you also need to change the JavaScript code generation, which happens ahead of time.
Right. The CLI would have to like read the Wasm binary and then understand what version of Rust produced that Wasm binary, and then it would have to like dispatch based on which version of Rust, which ABI is being used and things like that.
What is a CLI? You
Oh,
mean
sorry.
like command line interface?
Yes, that's the Wasm -bindgen CLI. Sorry, this is all very specific to Wasm bindgen as well. So I could try and boot up a lot of context on
No,
Wasm
it's
bindgen
okay.
itself.
I
but
think I
yeah.
get the idea. It's a pain in the ass because it changes the behavior and you have to coordinate that across all these tools.
Right, and I don't mean to say this is impossible. Like, I'm very glad this is an unstable ABI. I don't want to stabilize any of this until we have a lot more certain about all this. So like, this is all possible to an extent, but this is also like, this isn't the only motivation for adding this. It's just a big component too.
Okay.
So clarifying then, the goal is to have a version of Rust that supports both ABIs simultaneously as part of the transition, and that's why we can't just change the C ABI.
Correct. So like with this proposed ABI, the idea is that we would add this to Rust. I would wait for that ABI to reach stable Rust, and then I would change Wasm bindgen to saying, I'm going to use extern Wasm everywhere instead of extern C. And then that version of Wasm bindgen is only compatible with some version of Rust compiler and above, but you get like a compiler error if you use the wrong compiler.
Would you imagine that there would be a future version of Wasm bindgen where you would switch back to using extern C?
No, the semantics of extern C are not what I want. I don't think it's what anyone wants for Wasm bindgen's use case. Like, there's no purpose of passing a string with the pointer length indirectly. Like, the pointer length should be arguments. So like the semantics of what happens today, what arguments go where, is exactly what I think everyone wants for Wasm bindgen. And so I wouldn't switch back to extern C.
Even if
Got it.
extern C changed to match extern Wasm for now.
Well, I mean, if extern C changed, then yeah, it would be fine to change back to that. Like, basically the semantics of like an aggregate passed as an argument being multiple ABI arguments. Whatever ABI has that, that's what Wasm bindgen wants.
Is it the case that like you then just think that the C ABI that exists is like not good?
In my personal opinion, yes. But I mean, the C
Okay.
ABI was,
I'm
my
just trying to-
understanding is that,
yeah, I don't need to like quibble about the specifics of that like value judgment. I'm just trying to understand that
Okay.
that's like that's your issue. Like you wouldn't want to ever use a C ABI because you think that the Wasm bindgen ABI is better for reasons.
just for Wasm bindgen's purposes, yeah. Not like in abstract, just like for the purposes of Wasm bindgen. I mean, like the idea is that currently there's no easy way to target a precise WebAssembly signature with also some like nice things in between where you get to have like structs and aggregates and things like that. It just kind of doesn't have it. It has a little bit of an impedance mismatch, in my opinion.
So it sounds like there's going to be a whole bunch of questions about this, and we have a question queue at the bottom. We should probably go down that list. Although, Alex, please feel free to answer several at once if there is an overarching thing that we're missing and we're still in the middle of seeing the trees rather than the forest.
No, that's
Yeah.
fine. I'll keep going and then we can kind of come back to this. That's okay.
I guess Felix's question here.
Right. So Felix, to
Did
answer that-
Nico's question get addressed or not? The one with
I think so.
files? Okay.
Oh, there wasn't really a question about make files. That was just me being snarky.
Well, but I think it's a legitimate point to make that, like the statement breaking the ecosystem. It's a question of how big is the ecosystem we're talking about, and I think that's the point you're making, and I think it's
That
worth
is the point I'm making.
stating it at least.
Yeah.
I think it's good. It's important to acknowledge, like, if we change the C ABI for the unknown target, that is technically breaking, but I think that's a bug fix. Like, I don't think anyone's going to say, please don't break it. It's just, apparently I'm the only one saying, please don't break it for Wasm bindgen at this point.
Okay.
Anyway, so Felix, your question is simply correct. Yes, the extern Wasm would behave the same across all Wasm targets, and extern C would also behave the same across all Wasm targets.
And it'd be support, and extern Wasm would be supported across all Wasm targets.
Correct. All Wasm targets, just Wasm, I think, is the intention. I don't think the implementation currently gives you an error on like x86, but it should.
But I think I might have misinterpreted one thing in terms of the extern Wasm is the way you say that the arguments get splatted across the argument list, like the structure gets.
Right. I mean, it's just a different ABI. So like the ABI of extern Wasm is that when you pass an aggregate, the aggregate gets passed as individual arguments of the actual WebAssembly ABI.
Okay, I guess I need to go review what the extern C ABI is because I guess I would have expected extern C to actually do the same thing. So I'm surprised, but okay.
This
I'll
is
trust
where,
you.
I mean, The extern C ABI lowering is different for all targets, obviously. And so for WebAssembly, it just so happens that any aggregate is passed indirectly as a parameter.
And that's like a definition. All right, that's coming from outside, or that's something we
Right.
decide locally
Correct.
by.
That was
Okay.
a decision made by folks with Clang, and there's
Gotcha.
a document in like a tool conventions repository for
Okay, that's all I
WebAssembly.
need to hear. Thank you.
But Rust-C presently does splat, right?
The current state is that Rust-C supports both with the splatting and the not splatting. The not splatting happens on every single target except WASM32 unknown unknown, and the splatting happens on WASM32 unknown unknown. The
That's what I
history
mean.
there is that when I first wrote it, I did splatting because I didn't understand what I was doing, and then every other target doesn't use Wasm bindgen, so was able to be fixed. And unknown unknown is the only target Wasm bindgen primarily uses, and so
When you say other target, you mean every other WASM target?
sorry, yes, like WASM32 WASI, WASM32 unknown and scripted, things like that.
Got it.
So does that mean WASM32 WASI will not support extern WASM, or will support it and it will match extern C?
No, extern WASM will be supported on all WASM targets and will have the same definition across all WASM targets. So like the splat behavior is extern WASM and the non-splat behavior is extern C.
So that means on targets that already splat that it will match?
There's only one target.
No, there's only one target where the C ABI splats, and that's unknown unknown. And this would change. So WASM unknown, the C ABI would be switched to be not splat. And
I
then
see.
the WASM target, the WASM ABI for all targets would always splat.
Yeah, so C would always match Clang,
Right.
and WASM would do the thing we think is better, or Alex thinks is better.
Yeah, I want to say better. Just the thing that I'm proposing here, but it would be how I would summarize it. I don't want a passive value judgment on either.
There you go. It'll do the thing you want. Splat and multiple return values specifically.
Maybe we should call it extern Alex.
I mean,
you go.
just put Alex Wasm or yeah, something like that. Rust Wasm, I don't know. Anyway, so moving on, Felix has a question of summarizing unknown and WASI. The only difference is the standard library, where the unknown unknown target has no implementations of anything in the standard library. So like if you print, it just ignores it. If you try and open a file, it just returns an error. The WASI target, however, is built against the WASI APIs. So the WASI target assumes that it can import a set of functions defined by WASI, and this is like printing files, all that good stuff. Does that make
And
sense?
the purpose is what, deployment like targets in terms of where you're expecting to get to be launched, or what?
That's effectively where these are end up being used. So like on the web, you rarely can assume WASI. I mean, unknown was also the original target, and WASI was added later.
Gotcha.
So WASI is typically used nowadays in sort of non-web use cases, so like Wasm time, various engines like server-side use cases, and unknown because it is so limiting is suitable for the web, because the web doesn't have a standard runtime for WebAssembly or like a standard set of import functions.
Gotcha. Okay.
And this is also like, because WASI is so rare to be used on the web, this is why Wasm bindgen doesn't really target WASI that much, although there's not really a reason it couldn't, but that's why the WASM32 WASI C ABI already matches Clang. Okay, next question Josh has is the alternative of a different extern C worth exploring that would allow one Rust version to support both ABIs and that would have different stability guarantees if we did deprecate targets.
Yeah, I remember originally there was a proposal to have a new WASM target as opposed to a new WASM ABI, and I wanted to consider the alternatives there, because a different target has the advantage that if in the future C migrates to use the same ABI that WASM has, then we don't find ourselves stuck with both eternally, and we have the ability to evolve.
So the reason I would say this is probably not a great alternative is the primary reason for changing this is just so C and Rust can agree, and this is for projects that want to include both C and Rust in their project. So like basically, as long as extern C disagrees with Clang, if you use that target, you generally can't intermix C and Rust in the same project, which kind of sucks.
This is a key. I always kind of You said that it was in your
I
doc, but
see.
I kind of missed it. I think that's a key point.
Yes. But yeah, that is like the WASM32 unknown target. It's difficult. Like you have to manually audit to make sure you just don't have aggregates in your parameter lists to interop C and Rust.
I see.
And it would be great if you didn't have to do that.
So the goal here is that extern C can match the CABI provided by Clang on all targets rather than having. So to clarify, it sounds like you're saying it's not just that you want to be able to have both ABIs in the same Rust so that you can do a transition. It's that you want both ABIs in the same Rust because you might actually need both for different purposes, one for calling C and one for interoperating better with other modules in Rust or in JavaScript or with Wasm bindgen or similar.
Correct, yes. That's a great way to summarize it, which is C
That
is
was a very good clarification. Thanks.
yeah. And I would expand on that. So like C is you're matching C because you're calling C, and WASM is you are specifically doing something that is not C or something like you're targeting the WebAssembly target. And inherently as part of the WebAssembly target, functions have signatures which only take I32 and F64 and things like that. And so you're targeting a very, very specific signature for either importing or exporting or something like that. Like that is the purpose. Like a function pointer with extern WASM probably isn't that useful, but like that's the general mental model for WebAssembly or the Wasm ABI.
Next question. Do we
yes.
expect extern Wasm can continue to evolve?
So this is, there was another question that Taylor asked, which about what types we expect to be allowed, and we could solve a couple things with this. This is where like, I'm glad this is unstable because I don't think there's a great answer here. Right now, it's just kind of like whatever. And I think like a reasonable conclusion could be that maybe we only accept a subset of types in the extern Wasm ABI. So for example, WebAssembly only has I32, I64 floats, and now it has like V128 and extern ref and stuff like that. So we could limit the extern Wasm ABI to things that translate to that. So like integers smaller than 32 bits and aggregates. And we could say nothing else is supported. Like we could give you a Rust error saying this type is not supported. So U128 would not be supported. You couldn't pass a U128. And I think that would that would be I think a conservative stance saying we know how to translate these existing items into extern Wasm. And then when extern Wasm adds U128, then we just change our ABI and we start accepting that. So I think that would be like if we stabilize extern Wasm, I think this is required. So like we define the semantics for aggregates, we disallow enums, and then we disallow all fancy types that we don't otherwise know what to do. It's like U128, F128, things like that.
So like the C types lint, but a materially different set of rules on what's allowed.
Right.
And a hard error rather than a lint.
Right, a compiler error as opposed to a lint.
So is the intention there then that you could add new items when the intersection of WebAssembly, Wasm bindgen, and Rust agree on the best way to pass them?
I would say Wasm bindgen would be part of that equation, but just, I mean, I would say that new items probably wouldn't be added unless it's obvious that like that nothing new in the future will encompass that. So like, for example, U8, there's no Wasm type for U8. Wasm would represent that as an I32. And like, that's just a bag of 32 bits. So like, we would define that U8s are sign extended to 32 bits, 0 extended, and passed along. Like, that's obvious. WebAssembly is never going to add a U8 type. But for U128, we could define that as like passes to U64s. But WebAssembly could add a U128 type or an I128 type, so I don't think we ever want to accept that. So I think
unless we actually add that to WebAssembly, in which case we could add.
Right. So like anything new here would be like, it's obvious WebAssembly will never encompass this and we just forgot about it, or we need to wait to add this because WebAssembly might add something in the future.
If there were a Rust code that tried to use that, you would just expect an error. And so it would be up to the Rust user to translate their U128 to 264 bit words or something. Okay.
Right. Like if you wanted it to be 2 U64s, then you should convert that to a struct of 2 U64s. And our definition says that an aggregate would be splatted.
So because you're defining aggregates to be splatted, that also means that the contents of those aggregates wind up as part of the ABI, and so you wind up checking those as well. So that would mean that, you know, if you normally you don't require a rep/C or rep/Wasm annotation on types, right? Or anything like that on aggregates to
Correct.
pass
I
them
mean, I
value?
suspect that with this restriction, we would require that rep/C would be on these targets. I mean, we could even add rep/Wasm. I'm not sure if that would be whatever.
Yeah,
But the idea is
so the
we
reason I'm
probably
asking about
wouldn't.
rep/Wasm is because there's sort of a subtle like potential for breaking changes if someone, for example, adds a, you know, I-128 to their type, like their existing aggregate in Rust that maybe even is rep/C, right? And then you use them as a library and then pass that value through Wasm Bindgen. I don't know how real that use case is or not. Like you know way better than I do. I'm just trying to understand, like, is that a thing we need to guard against? Like,
Well, I was saying, I think we might want rep/C to, that's kind of an indicator of saying the fields must be passed in this order because the field order matters because that affects the ABI. But I'm not sure rep/Wasm makes sense, but only because I would probably want to support generics, which means that we would check the monomorphized version of a struct, and we wouldn't actually. So if you put rep/Wasm on something, you're just saying the field order matters, and that's pretty much it.
got it. And because you're saying you want to support generics, and so you're having to check the monomorphized type. So I guess I'm unsure I understand, like, I guess you're saying that like any values you pass along there are already sort of, you're not respecting any kind of like backwards compatibility guarantees about the contents of those types.
I mean, yeah, it's not, you wouldn't be able, I mean, if you added or deleted any field, you would change the ABI of any function that took that aggregate by value, just because you're removing or adding arguments.
Right, but changing the ABI isn't the concern. The concern is like it wouldn't compile anymore because you're now like you're now using a struct that has a non-Wasm compatible, Wasm ABI compatible type.
Yeah. Oh, yes, that is true. And yeah, I mean that's a downside. And like this is a thing where like if we do want to restrict the types in Extern Wasm, I could imagine it's actually going to be pretty difficult, and because like I'm not really sure what happens if you have like a generic function that has Extern Wasm as the ABI. It just means that certain instantiations are going to start getting errors. That's kind of funky because it's an instantiation time like monomorphization error, and like you're saying, it just means that like if you happen to instantiate that with the wrong thing, or like on some targets you're not even using this, but then when you compile for Wasm, then you start getting errors. Like that's going to be real funky and it's going to be very odd. I don't.
That seems in the weeds. I mean, it seems
Sure.
important, but I want to make sure we keep going. That's all.
Yeah, I mean, let's go ahead and go. And I think we can come back to this aspect. That's okay.
So I wrote, is it an accurate summary? But I think this has been covered by previous conversation. I don't think we need to answer that. Taylor has the next question, but it seems like we were just talking about this too.
Yes, I was trying to talk about that the previous one, yeah. The other aspect, Nico, in your question though, unlikely to be updated in a reasonable time frame. I don't know that. It hasn't changed, and I'm unaware of any plans to change it. I would not pass a judgment whether it's likely or unlikely. I would want to literally confirm with the folks doing Clang stuff.
But even if it does change, we don't know how likely this would change in a way that's compatible with what Wasm wants to do, right? That seems as much an issue.
Correct. My impression is that the CABI has been selected based on performance and not based on expressivity so far. And so it's unclear whether that would work for these use cases. But I mean, I think there's also a reasonable thing here of like, if C picks an ABI and they're really sticking with it, like especially for the multi-value aspect, at some point, Wasm Bindgen should just put up a shut up and actually go get fixed.
Yeah.
But let me go to Taylor's next question. So what level of documentation and stability guarantees would we offer to Extern Wasm? So this is kind of what we were talking about earlier. Like I would expect that we would have documentation for what like the goal of Extern Wasm is, given a Rust signature, you can predict the precise WebAssembly signature. And so I would expect documentation of exactly what that is. So like we don't allow generics. We do allow generics. This is how they get splatted. This is how U8s get sign extended. Because this is, I mean, it's also Rust specific. This extern Wasm wouldn't exist anywhere else in the WebAssembly ecosystem. So I would expect us to have lots of documentation and pretty strict stability guarantees because we would want to continue to migrate this with WebAssembly. Now, whether that can all be achieved is another question, but does that make sense?
So we would expect, in other words, that like someone else could write a Wasm bindgen and replicate what it does in the JavaScript code, right, to line up with the output of an extern Wasm ABI.
Yeah, I would not expect that documentation would mention Wasm bindgen at all. It's more, this is all just kind of, a lot of this is motivated by Wasm bindgen, or Wasm bindgen would use this because Wasm bindgen can then predictably say, like, given this projection of this trait, of this, like, given this trait associated type projection, I know precisely that the ABI is going to be this, things like that.
That makes sense, thanks.
I realize now, that hearing your answer to this question, that I was not clear on one detail. That I think you said it earlier, but I just want to make absolutely clear about this. You gave the example. You've given 2 examples of things that aren't part of Wasm, U8 and U128. And my initial interpretation was that you were saying that extern Wasm would not support passing either of those things. But I now realize that what you in fact are saying is that the plan is that things like U8 would be supported and would have a defined semantics for how they are translated into the Wasm compatible thing, namely sign extension or whatever. While
Precisely.
things like for some reason, certain things like U128, because they might be supported in the future by WebAssembly, they're going to be rejected by extern Wasm. Is that the idea?
That's the theory. I mean, I think it doesn't really stand up to a lot of scrutiny with that kind of, like, I want to do that. I think that would
No,
be good
I don't. I
because-
wasn't trying to scrutinize. It was more. My initial impression was that you'd reject everything. That isn't the way defined.
Right.
But that's not the plan. It sounds like because you want to make it easier for people to still have like pass structs in and things like that, and thus you don't want to just reject all U8s that are all structs that have U8 in them, for example, right?
Right, exactly. Like I the goal is still to have general Rust code work as long as the Rust code is generally well behaved. And then for types like U128, which are honestly very rare to cross between JavaScript and WebAssembly or things like that, if we reject those for the time being, no one's going to lose too much thought or tears over that.
Okay.
Okay, the next question from Mark: are we expecting C and Wasm?
I think this is answered. So
okay.
we can.
Yes, they will not be synonymous. Yeah. Next, Josh, will extern Wasm exist on other targets? My goal, I would probably say no. I don't really want to consider that. I want to say it's just a compile error. Like, I think there's already support for ABIs only existing on some targets, not others. And so I think we would just extend that.
So corollary to that, though, if we don't define extern Wasm on other targets, then I can imagine people wanting to define the same function on two different targets where the only difference is what's in the extern Wasm versus extern C. And that's a bit of a pain to do right now because unlike config adder, you can't make the contents of what's inside the string constant there dependent on a config variable. So would it make sense to either add an attribute equivalent to extern that can be done with a config adder, or tell people what the ideal pattern is, like defining a macro?
I have done this with macros in the past, but I do think that would be a downside. And I mean, Scott just put there like extern splatted, and like, I mean, I don't really want to be the one to add a new ABI to Rust just because I disagree with splatting and Wasm. Like that feels bad. But if it comes to that, like if it really is useful for others, I think that's a possibility of like just supporting Wasm or supporting something like that on other targets. I'm not sure if config adder would work because it needs to be part of the type signature of the function pointer, or like of the type of the function if you take a function pointer. But yeah.
Fair point. It's more, whatever pattern we decide is ideal for defining a function that's identical everywhere except that it uses Wasm on Wasm targets and C elsewhere, we should explicitly say, here's the pattern we recommend, and if that pattern is too painful, we should make it a better way to express that pattern.
A macro
Yeah.
that contains the items could hypothetically do it, right? Even just a macro rules one.
Yeah.
I mean, it might even be possible to just define a macro that expands to either Wasm or C, and then just do extern that macro. I'm not sure if you can put a macro there, but we should.
I would bet you can't put a macro there right now.
We might be able to fix that.
It does seem like, from what I've heard so far, that it would be pretty like the predominant use case we expect for extern Wasm is for like Wasm bindgen and potentially other tooling that really precisely is intended just for this use case of, you know, passing to across a sort of Wasm ABI to some other language. And so it would be not necessarily typical that you would want to do this for like a user written function in some sense.
Well, I mean, so there are hypothetical ideas. Like WebAssembly is going to get this thing called interface types, which is intended for like, here's a type grammar by which you can communicate with the outside world in a what we're calling shared nothing. So like you don't have to share memory fashion. And that's giving you the ability of like, even in native code, you could have a WebAssembly interface types thing, and you could like define a native plugin based on that. And then the same ABI that you're using for your WebAssembly module, in theory, could be this exact same ABI you use for your native module. And then it just so happens that like, you're using all the same stuff, and like, it's a very far-fetched kind of very far in the future idea, but that's a possibility where like, you might want literally the exact same function, like for if you're defining a plugin to be compiled both to Wasm and to native code. And that's because the runtime on both sides just understands this type is serialized this way and has this definition on this architecture or this host.
Right, but that target might be a Wasm target still, if in that hypothetical future, right? Like you would have a, I don't know.
Oh, no. I'm like, I mean, certainly you could run Wasm on native host, but I mean like, you write a plugin in Rust, you could compile it to WebAssembly, which has like the Wasm ABI, but then you want the exact same functions to also be able to compile to x86 64 Linux. And
I see. Okay.
it uses like it uses an actual native, like very unsafe code segfault kind of ABI. Like
Okay.
it's very hypothetical, and that's where like, if we only allow extern Wasm on Wasm for now, that's what I would probably say, just to be conservative. Just we can allow it in the future for other targets, but yeah.
Okay.
All right. The next question for will the C ABI and Wasm ABI merge? I think we decided about that. So no, they will probably not. Is the intention. If they do merge, then Wasm doesn't make any sense. We would just use the C ABI. I mean, but this does bring up a point about multiple returns, which we haven't talked a ton about, but this is a second motivation for the Wasm ABI, which is the multiple returns idea of WebAssembly. And so the canonical C ABI today doesn't support it because multiple returns weren't supported or weren't allowed when the C ABI was created. And this would be a way for us to roll out multiple returns support in Rust without having like brand new targets or like brand new ABIs and things like that. I've seen that, like, for example, we have ARM targets for soft float and hard float, but they are entirely separate targets. In theory, you can control this with codegen flags, but because the entire world has to agree, it's kind of sucks to have, it makes more sense to have multiple targets. And so I honestly think it would be really nice to not have different Wasm targets for multi-value returns. And so, like, I don't want the Wasm target and then the Wasm multi-value target, because with the nature of WebAssembly features, everyone will eventually use the Wasm multi-value target, and there's no reason to use the original one. So using this at the ABI level gives us the nice ability to say, like, well, it's just, this is the ABI for having multiple returns. And so I don't have any idea what Clang is going to do here. My guess is they're just going to add a codegen flag and say compile the whole world with the right codegen flag, but this I want
to try and make sure I understand the metaphor or analogy you're drawing here, because you gave the example of ARM targets with soft float and hard float and said, like, this is that's a reality. Like, that's something where there's just hardware support for floats in some ARM systems and software and no hardware support, and thus you must, and the whole world has to agree on which thing they're running on.
The other main
and so
difference is the ABI. So like different machine registers are used to pass floats in
yeah,
functions.
but
and things
my
like that.
point is that the analogy here, I would think, is about which virtual machine you're targeting and whether it's sufficiently new to support multi-value return, right?
Yeah, and I would hope that if you're using like 2 years from now, you're using the latest and greatest VM, which has multi-value return support. I would hope that you are using the WASM 32 WASI target. I don't want you to have to use like the WASM 32 WASI multi-value target. If that makes sense.
I guess I'm just, to me, the analogy still in my mind works in terms of saying the whole world, if the whole world has to agree, in this case, it's a matter of which kind of virtual machine you're targeting, then it still seems like multiple targets makes sense.
Well, this is where, I mean, so the multi-return is a backwards compatible extension to WebAssembly. And so all existing VMs are going to support this. So you're like, it's within 6 months to a year, it's going to be very rare to find a VM that doesn't support this. But there might still be people that want to compile WebAssembly without multi-value for something, I don't really know what, but and this is where it's slightly different than soft float and hard float, which is like fundamentally different runtimes. But this is something that this isn't really a fundamental difference of the runtime. It's just whether the runtime supports it or not. It's very easy to add support for most runtimes. I don't know if that's really answering your question.
Do you agree, Alex, with what I wrote there? That basically the difference is the WASM is still in flux and we expect all VMs to support multi-value return in the not
Yeah,
that distant future.
yeah, I think so. And like, but I guess the other thing I would add is that the ABI is just so pervasive where it affects the entire program. So like there are features you can add to WebAssembly like new instructions, and that can be very localized of like, I just my function either uses the instruction or doesn't use the instruction. And it's a very easy like CFG as to whether it uses that or not. But this is different where like we're talking about how I interact with the outside world or how the standard library will interact with the outside world. Like for example, eventually WASI, the standard, is going to have a specification where functions that you import will return multiple values. So the standard library is going to have to make a choice. And so I would love for the standard library to just say extern Wasm because it is binding the signature of it returns multiple values. But interaction with, like, we don't have to wait for the C ABI to update. We don't have to wait for agreement on C for whatever C is going to be for multi-value. I honestly have no idea what C is going to be for multi-value.
So the
We have-
intent there then is that even if the standard library uses extern Wasm rather than extern C to export some things, then that'll be fine because Rust is calling that. It doesn't need to be, JavaScript won't be directly calling std without an intervening exported function.
This is more about imports of like the Wasm module will import a function in the WebAssembly file that returns multiple items. And that's sort of like, that's the, like if we bind WASI and WASI changes to have functions that return multiple things, we literally can't do that today. And so this would be the only way, this would be the way to do it is, and we can divorce that from C of like whatever Clang wants to do for the current C ABI, we would match it for Clang, but we're not binding Clang if we're targeting WASI, we're targeting like a WebAssembly function signature.
Silly
Okay.
question, perhaps. When Rust is doing multiple return values, is that like if you return an aggregate, it puts them in multiple return values?
This is kind of not super well defined because it's not really well supported today. The answer is if you literally return like a Rust tuple, you'll get a warning saying it's C ABI incompatible, and then it'll do the right thing. I think the way, so it's sort of like a question of how do we want to model this? I believe the way LVM is supporting it, like just at the LVM layer, is you return an aggregate by value, and then LVM translates that to a multi-value return. And so we could do that, and that probably honestly is what we're going to do. But we could also just as similarly say, we define the extern Wasm ABI as supporting Rust tuples in the return position, and that just naturally translates to multiple return values. Like you don't get the lint saying that's not extern C compatible or whatever. So like basically, it's up to us. We get to decide what to do here, and by not trying to match C precisely because we're targeting a specifically different ABI, that gives us some leeway of like supporting Rust tuples, or just saying that the first level of aggregate is splatted, maybe the others aren't. I don't know, something like that. Does that make sense?
Yeah, that makes sense. Thanks.
Okay.
There's 2 questions left and 8 minutes, but alternative solutions.
I guess I should say
covered
the main
some.
one there is C. So work with C so the C ABI works for everyone. And this means that not only does the desired semantics that I personally want Wasm BindGen to have for arguments, but also having some story for the migration of the C ABI from what it is currently to multi-value, which I honestly have no idea what C is going to do there, and that would be good to hammer down. So like that's hammer that down and see if that story supplants the need for Extern Wasm. That's the main alternative solution I can think of.
It does, based on the previous conversation, it sounded like that solution doesn't quite fit the need of sort of, obviously you can sort of hard code what C does, but in theory at least, it doesn't necessarily fit the desire for a very sort of simple and straightforward translation that hard lints or errors on not understood things, unlike the CABI, which currently, at least from what I know, is more like sort of best effort in some sense.
Yeah, no, I agree. That's a downside to using extern C, which is like all these problems about what, like the extern C ABI will define what happens when you pass a U128, and that will not take into account what if U128 is added to Wasm in the future. And so the answer from the C side of things is it'll break. And if the C ABI breaks, it's like, do we just inherit that breakage in Rust? Do we want to insulate users from that in Rust? That part's a little unclear to me, because like we could, if we separate Wasm and C, we could insulate users from breakage in C by saying you just have to make sure you're using the right Clang with the right Rust. But if we're using extern, like, but otherwise, if you're talking outside of Clang, so you're talking to a host environment or to JavaScript or something, then you're using extern Wasm, and that is a very stable ABI, which we're never going to break. That's like, we could separate, we could take that insulation of breakage on ourselves, or we could just follow C and say like, well, they broke everyone, so we can break everyone too. That's my impression of what following extern C would be. But I should say, like, naturally, that story would be very heavily influenced by what C's actual desired route of migration is, which I am unsure of.
Last question. Would there be a use for RepRWasm to go with this?
That's what I was saying of like, I think so, but only like if we define the ABI as aggregates are splatted and splatted in the order of the fields there, then RepRWasm might be useful to say, okay, it really is the order of the fields there, but we would still have these monomorphization errors of like, you used RepRWasm where the struct had a trait and the field was a trait projection. And then only during monomorphization do we realize that was a U128 and should be an error. So we could also just rely on RepRC for this. Like RepRC says the order is defined, and then the RepRWasm on the lowering layer just gives you the monomorphization errors. But either way, I would suspect that if we do validation of arguments, if you have an aggregate and a parameter, we would validate that something is on there, either RepRWasm or RepRC. It's mostly just like, I don't, RepRWasm could disallow a raw I128 field, but couldn't disallow like a generic I128 field. And so I don't like, yeah.
But it does sound like a way to keep the error messages, because my understanding is without RepRWasm, you're going to get those errors at the time when the call is made, right? Which might be actually downstream from the definition of the type.
My point is that that'll always be the case, because even with RepRWasm, if you have some sort of generic parameter,
sure, there's cases where, okay, there's cases where with generics and whatnot where where it's hidden right behind some level of indirection. But I can imagine cases where it's not, where it is apparent up front, and without RepRWasm, you won't know it until somebody actually writes the code that makes the call. That
right. So RepRWasm could front load some errors, just not all the errors.
Right.
On the other hand, that seems to exacerbate the problems that Josh was saying, where like we were concerned about functions that might want to use both WASM and C for interoperability. It seems much
Mhm.
more likely to me to have structs that you might want to pass across boundaries.
That's true.
Yeah. I personally would be inclined towards just use repr C, and then if you pass that in repr WASM, then we will pay close attention to what types are in it. And yeah, you might get a monomorphization time error, but so be it. And I don't think we can do better than monomorphization time errors, because with repr WASM, if you have a generic, then you have to have a monomorphization time error.
Though the problem that Josh described previously was something where that in part was arose because the extern C block doesn't give you a way to say, you know, I expect to be working in C in some contexts and WASM in others. I feel like with repr, the repr attribute, you do have a little more flexibility, or we could even extend it to allow you to say repr C comma WASM to say this struct needs to work in both contexts. Like it doesn't sound like as difficult a problem to solve, I guess is all I'm saying.
You can use config
Right.
add-on.
Right, that as well.
The WASM thing seems like just potentially it would be an extra set of, you know, requirements on the type, right, rather than a separate ABI or separate set of like repr guarantees than C. The one thing that I don't know, I feel like I've been sort of convinced that this isn't necessary, but the one thing I do like about repr WASM is that then libraries exposing types with like private fields internally, right, would, as I understand it, it's a breaking change for them to add like a U128 to their struct then, or something.
Only, I mean, it would already be a breaking change to
forcing-
add a field, wouldn't it?
Why is it a breaking change to add a private field to a struct?
An ABI breaking change.
So if you add a
Sure,
private
so I'm
field,
not concerned about ABI breakage. I'm concerned about like my code doesn't compile anymore, right? Because I was using this type on an ABI boundary, and now I'm not allowed to anymore. Maybe, I don't know. Maybe that's not a real problem. I'm trying to
Well,
understand. Like,
I mean, I think your point is like, if you recompile the world, you don't care about the ABI breaking change,
exactly.
but you do care about this other change.
Yes.
Which seems
I have
correct.
a hard out. I was debating about whether I should check people's temperature or not about this overall at this point. But I don't know if that's a good way to end the meeting.
I think we can do it on Zulip. I'd like to, yeah, I'd rather end the meeting and think about it.
Thank you, Alex, for your time here. This has been very useful.
Thank you all for having me.
Yeah. Thank you.
All right. Goodbye, everyone.